The last couple of weeks you'll be working on an unknown project, and I'm going to be giving you result sheets and worksheets to fill out, and you'll use the information in your lab manual, the biochemical handouts, any videos that have been uploaded, the picture atlas, your lab manual, etc. to fill these out and to write a report. So the worksheets are going to be due, there's 2 of them, in the drop boxes, and if you don't upload them when I grade your final lab report, I will deduct 5 points. So starting the week of June 29th, I will have your result sheets and worksheet up, fill it out, get it into the drop box by 11:30 p.m. on July 5th. Then the following week, I will again have a result sheet and worksheet, fill that out, get that in by July 12th. Now, for the final week of the semester, the week of the 13th, all you're going to be doing is working on your lab report, a flowchart. I'm going to be uploading a really good tutorial for you guys on that. And basically what you're going to do then is upload a final lab report based on all of the results, the worksheets, your flowchart by Monday, July 20th. Now, I gave you an extra day on this because your finals are going to be that weekend. Please note, I will not accept late lab reports. I will not accept emailed lab reports. You have to have the lab report in the Dropbox no later than 11:30 p.m. on July 20th. Now, I will be uploading a spreadsheet with all of the bacteria and their results, either the week of July 6th, I may do it the week of June 29th. I'm working on getting that finished for you guys. Again, I'm going to send a tutorial on how to make flowchart. I will upload a couple of examples for you as well, because I suspect most of you haven't ever worked on flowcharts before. Okay, so your flowchart is something that can be drawn by hand, or you may generate it in Word, PowerPoint, or some other program. So just take a deep breath, take it one step at a time. Don't try to do everything at once, and you guys will be fine with that. Now, as far as the lab report goes, this template has been uploaded for you. So I would like you to make sure that you fill this out. I want this document either Word or PDF. Okay? I can't accept any Mac formatted documents. So all you have to do here, guys, is make a title for this, unknown project, whatever, put your name, and then your unknown ID is your section number. Your section number for the lab. So once you fill that out, then you go down here. You write me a purpose. Why would you be doing an unknown report? Well, if you think about this, the reason that you do an unknown is because it's similar to what happens clinically. A patient comes in, they have an unknown infection. Nobody knows what it is until they do testing. So that's the overall purpose, is to familiarize you guys with how things are done clinically. Then you will have an introduction. So again, guys, all you have to do, use this as a template. You delete that sentence here, write your purpose out. Introduction, it's already labeled. Delete this stuff, write an introduction. Now, an introduction is background information. So you can go through all of the tests that are on those worksheets and explain what they all mean. If you do that, you're going to have at least 2 pages. Okay? Now, as you're writing this, you can also use your lecture textbook. That's a good source as well. It explains all the different microbes that are out there and all that cool kind of stuff. Please do not use personal pronouns, I, we, us, they, etc. Those are not permitted in scientific papers. Also, if you are using information from any outside source, which you will be, please make sure that you're citing it, author and year. No quotes. In science, we don't use quotes, so you have to write in your own words. This is very important. Your own words. Don't copy and paste. Then we have a results section. So what you're going to do then is you're going to provide me with a list of materials and any reagents that are used for worksheet 1 and worksheet 2, and then explain the methods. So here's a good way to do it. Write down worksheet 1, then list the materials that are needed for the PEA, EMB, urease, etc. Then you're going to put a heading, methods. Then go 1, PEA. And all you have to do is say, unknown was aseptically streaked onto a PEA plate, incubated at 37 degrees, etc. EMB plate, write it down, how it's inoculated. Same with urease, how do you do the gram stain, how do you do a KOH test, etc. So explain that. Use the lab manual. It has all of these techniques in there. Also, if you're not exactly sure, if you look back at the aseptic technique video I put up way back at the beginning, I demonstrate how you inoculate different types of media. So you're more than welcome to look at that, utilize anything that you have. So materials and methods section. Now for results, fill out this chart, okay? So give me a brief purpose statement for each one of the tests. So for instance, purpose of the gram stain is to differentiate between gram-negative and positive. If we go down here, catalase test, for instance, is to determine whether or not the bacteria produces the enzyme catalase, etc., etc. So you give me a brief purpose. Your observations, all you have to do, class, is write what you see from your results pages. All right, so you're filling out the worksheets. Take the information from the worksheets. Tell me what you observed for the gram stain. What did you observe for the KOH? What did you observe for EMB? And I'm going to give you an example at the end of this video on what I mean by observations. So based on your observations, then you interpret what that means. Look at the videos for the biochemical testing. Okay, look in your lab manual. So for instance, if you observe red rods for the gram stain, that means that you have a gram-negative rod. Let's say for EMB, you have green metallic growth. That means you have gram-negative and a strong fermenter. So you do that for all of the different tests, okay? Don't record plus or minus for interpretation. Write down if it's positive for an enzyme or whatever it is positive for. Now the flowchart again, please look at the video tutorial that's uploaded. It's really good. It will explain to you exactly how to do your flowchart. Now, some of you are pretty tech savvy. You've got a lot of different kinds of programs at your disposal. If you do, go ahead and generate the flowchart in one of those programs. However, if you are not, you can hand draw the flowchart if you'd like, and then upload it as a separate file. Now, I will tell you this. If you take a picture of your handwritten flowchart, please convert it to a PDF. Last semester, a lot of students had huge files. They were unable to get it in the Dropbox, so convert those. Also, I'll be honest with you. If you just insert the flowchart right here, okay, right here, it would make it a lot easier because the whole document can then be uploaded as one file, but I'll leave that up to you. For discussion, minimum of 2 pages. So first start out by explaining your results and how you figured out what your unknown was. So kind of use your flowchart as a guide for that. That's how you'll start out. Then in bold, state my unknown is whatever it is. From that point on, what I would like you to please do is just discuss your unknown bacteria. These are ones that are pretty common. Use some outside sources aside from the textbook and lab manual, please. Find at least 2 other outside sources. References should be APA formatted. Now, I want you to be aware of this. As soon as you upload your lab report, it's going to be scanned in a program called Turnitin. Your match should not be higher than 25%. If it is, points will be deducted, and if your match is too high, and I'm going to be looking at what's matching to determine if you're just copying from another source, which is called plagiarism, you may receive a 0 on this report. Don't copy, don't plagiarize, okay? So you can upload, if you upload a draft early enough, you can check your match, and if it's too high, go in and rewrite the sections that match so that it gets to 25% or below. So the last document regarding the lab report itself is the grading rubric, so you know where points are assessed. So your purpose is 2 points. Introduction is going to be 5 points. Material and methods is 3 points. So you can be brief when you describe how you do each one of the experiments. Results is 15 points. There's a lot in that particular chart. So I'm going to be looking at everything, make sure it's accurate, etc. Your flow chart is 5 points, discussion is 10. References, again, I'm going to be looking if you have in-text citations, if it's APA formatted. Now, I want you guys to be aware of this. Getting it right is only 5 points, okay? This lab report is worth 50 points, so that's 10%. What that means is even if you get it wrong, if you write me a really good report, I can see your flow of thought, etc., it's still possible to get an A, okay? So just relax when you're doing this project. Now, the last thing that I would like to include in this video is a little bit about the worksheets. So you're going to be given 2, and on each worksheet you're going to first start out by looking at, let me back this up a little bit. So you're going to have a results sheet. So on the top here you can see results for the PEA, EMB, urea, gram stain, KOH, catalase, and oxidase. So on the bottom, what you're going to do then is you're actually going to write what you see. So for instance, with PEA, there's no growth here. So you write no growth. This doesn't show too well in this, unfortunately, but for the EMB, if I can zero in a little bit on that, for EMB, it's actually a green metallic color. It's just not showing up too good on here, but it's a green metallic color. And then for the urea, and I'll be uploading this PowerPoint for you guys to take a look at, so you'll see the colors better. But for the urea, it's just pink at the top. Gram stain, those are actually red rods. For KOH, it's sticky. There's like this little bit of a line here. Catalase, bubbles. Here you see it's yellow. Now I'm saying yellow, not blue, for a reason. Sometimes when you do the oxidase test, it'll get a yellowish color because of the bacteria. A lot of times it's just white. So you just record. If yours looks yellow, that's fine. If yours looks white, that's fine. Also, and in some cases, it's going to be blue. If it's blue, that's your positive result. And then lastly, guys, for the PAD over here, it's actually a gold color. Okay, so that wraps it up. And as always, if you have questions, please contact me. I'm more than willing to help you guys out.